Welcome to today's RAVENNA webinar, the first one in a row of webinars which covers products and applications. Today, the webinar will be held by Ross Video, and it's touching on various methods of bridging AOIP solutions with the Ross IGGY platform. So, thank you everybody for joining us. As always, a quick bit of housekeeping. We have a Q&A function with the GoToWebinar. So if you like to ask any questions, please use the Q&A and we will address them at the end. All right. Of course, the presentation will be available in 1 or 2 days, the slide deck as well as the recording. Just turn to the RAVENNA webpage, the events section, where you will see the upcoming events as well as the recordings of the previous events. So without further ado, let's jump into the topic of today. I'd like to introduce our presenters from Ross Video. It will be Bill Renopoulos, who is a business development manager for the OEM and partnerships. He's based in, well, I guess it's Toronto. I'm not sure. He can tell us in a minute. Okay. So then we have Angelo Santos, who's the solution architect for the IP solution signal processing here. He will cover the technical part of the presentation. So welcome, Angelo, as well.
Thank you, Andres.
Okay. So I guess that's it for the introduction. If you want to add something, just go ahead. And without further ado, I'll pass it over to you. And Angelo, Bill, just go ahead and take it from there.
Thank you, Andres.
Thanks, Andres. Hello, I'm Bill Renopoulos. I will be presenting today with my colleague and indispensable team member, Angelo Santos, our solution architect for IP products. And we will introduce you to our IGGY family of IP audio bridges. First, we'll do a little bit of marketing. I promise not too much, as I quickly review IGGY's platform's key features and the various product members in the family. Angelo will then go into deeper technical detail as he covers the block diagrams and then goes through an in-depth review of several interesting bridging applications, followed by a demo to show IGGY in action before we wrap up. Now let's look at the IGGY family. So IGGY is our family of compact, full-featured audio over IP bridges, offers the most broadly interoperable, flexible, and robust RAVENNA AES67 2110 implementation on the market from our perspective. IGGY's convenient form factor provides incredible flexibility to effortlessly deploy IP audio bridging wherever you need it, whether that be in your studio, truck, on stage, or in a fly pack. As we like to say, don't let bulky equipment or incompatible AES67 2110 implementations get in your way. Get IGGY and get groovy. So a little deeper into the features. IGGY is compact yet full-featured, easily deployed anywhere without any compromises to number of channels or any other features. It's broadly interoperable audio over IP, a mature and complete set of AES67 and 2110 options, together with flexible clocking features. IGGY ensures you get a solid connection every time. Effortlessly adapts to your environment with broadcast-grade robustness, power over Ethernet, hitless 2022-7 audio interfacing, while it's designed to be silent for in-studio use. Networked audio without barriers is another feature. Natively bridge multiple audio networking solutions and protocols together, such as those listed in the slide. Next slide. Let's dig a bit deeper into the tremendous number of open control features available on the IGGY platform, covering discovery and registration, configuration, and connection management. For registration discovery, IGGY supports RAVENNA, NMOS ISO4, SAP for interop with Dante, for example, QLAN, and certain Dolby products, and also LiveWire Plus on certain models. Many connection management options as well. Please note here, there is a basic version of NMOS available on IGGYs today. There will be a full NMOS ISO 4 and ISO 5 version available shortly in an upcoming release. Configuration choices include JSON API for configuration from any web-connected device and a web UI for quick and easy setup. You can also have access to GPIO through ROS Talk, a proprietary protocol from ROS, and Tally via the common TSL protocol. Please note there is no support for proprietary transport formats like Legacy Dante and LiveWire. Now let's review some of IGGY platform's networking features, specifically AES67 and 2110. So we have up to 64 audio receivers and 64 audio senders. I already mentioned 2022-7, both on the sender and receiver side. We have packet times from 125 microseconds to 1 millisecond, sample rates 48 kilohertz and 44.1 with ASRC, 88.2 and 96 kilohertz without ASRC. We have up to 1 to 80 channels configurable per audio stream, and a ton of audio formats, common ones from L16, L24, L32, including RAVENNA AM824 and ST2110-31, all configurable per stream. Then we also have a lot of flexible clocking. So IGGY can be used as a PTB slave with recovered word clock, or you can also use the word clock input to use IGGY as a PTP master. There's multiple supported PTP profiles from the default 1588 v2 to 2059 for 2110 to the media and GPTP options. Looking now at some mechanical features, 3 IGGYs fit nicely and securely in a 1RU shelf. There are no fans, so as we said before, IGGYs are super quiet, perfect for your studio. Another feature of IGGY's adaptability to your environment is power over Ethernet, perfect for when finding a plug is an adventure or just not possible. There's also an option for a backup brick to ensure you never run out of power whenever your application requires it. IGGYs come with locking connectors and rugged Nutric RJ45 connectors, and a robust metal throwdown enclosure that can take a beating whether used on the road or during a live show. Sticking to the mechanical theme, IGGY's adaptability also is an advantage here. In addition to the 1RU rack shelf that we presented in the previous slide, and taking inspiration from our NUT 2110 to HDMI or SDI video converter, which is in an identical form factor, there are multiple ways to mount, affix, or hide your IGGY. These include the potential to use a tie wrap, or you can order mounting ear brackets to put an IGGY under a desk or a table. There's also an option to use VESA brackets to affix an IGGY to the back of a monitor or similar device. Now let's turn our attention to the various members of the IGGY family. We have a MADI, ASCBU or AS3 version, and a 1RU, and many more exciting variants are on the way. So you'll be seeing more soon. Now turning to IGGY-MADI. IGGY-MADI is our compact, broadly interoperable and flexible live audio over IP to MADI bridge. It cost effectively supports 64 or 56 MADI channels in and out. There are coax and fiber options, including both multi-mode or single mode, available via SFP. It easily goes anywhere and is tough enough to withstand most environments where you need to bridge your MADI audio to a RAVENNA AES67 or 2110 network. IGGY AES1616 is a compact, broadly interoperable, and flexible live audio over IP to AES3 bridge. It allows you to handle 16 AES3 channels in and out via DB25 connectors with a Tascam print pinout, and you can take its svelte form anywhere as it takes up very little room. Important when space is at a premium, enabling you to have the freedom and flexibility to bridge your AS3 audio to IP wherever you need it or want it. Now turning to the IGGY-1RU. IGGY-1RU is a fully modular, broadly interoperable AES67 RAVENNA 2110 audio bridge solution, offering you the mix and match freedom to choose your baseband audio flavor, whether that would be MADI and or AS3, and we will be offering others in the future to interface with your IP network. The IGGY-1RU is architected to fit 3 compact IGGY IP audio bridges. You can choose any combination of IGGYs, buy exactly what you need. This allows you to perfectly align the IGGY-1RU audio IP bridge to your project and technical requirements, with the added advantage to be able to repurpose the individual IGGY bridges in the future, giving you incredible flexibility. You also get unparalleled channel density in a 1RU with up to 36 AS3 channels in and out. And as with all IGGYs, you get open control with the support for a plethora of discovery, registration, and control protocols to enable control and monitoring your way and the versatility to connect to any network. Now I'm going to turn it over to Angelo, who will start with some block diagrams before getting into the applications.
Okay, thanks, Bill. Just for you guys to know what is coming. So I'm gonna go through some more details in terms of implementation and I'll give more emphasis on the innovation side. I'm not gonna be talking too much about the network part, which is pretty known by the RAVENNA community. So if you look at this block diagram, you can see on the MADI side that you have an ASRC, async sample rate conversion on both sides, CX and RX. And the other thing interesting is the audio shuffling, or we call the audio cross connect. You have full flexibility to put any channel from the MADI interface to creating streams to the network side, and vice versa. You can receive streams from the network, and then you can map any channels to the MADI interface. And as Bill said, this has a lot of flexibility on the clock scheme. You can use an internal clock, or you can receive a reference clock to even become a master or a slave. And on the top, you can see the GPIO connections that you can control both from the control port and from the media port. The IGGY-MADI is similar block diagram. On the network side is pretty much the same. And we also have the same flexibilities on the MADI, which is the ASRC and the audio matrix shuffling cross connect, as well as the clock, the word clock in and out for reference. Now I'm going to talk a little about some applications. You can see here it's for audio production only. You see on your left side, you see the IGGY-MADI making a bridge between the IP network and the Ultrix. For those who don't know, Ultrix is our router, SDI router, and you can make a very nice connection between the audio network to the SDI word through this IGGY-MADI box. And below you see the AES3 interfaces to IGGY, and as you can see, there is also flexibility for GPIOs and DALI. I'm going to talk a little bit more about that in the future. And once it's on the network, you have all kinds of things you can do. You have the you can do audio processing, can do mixing, and even interact with like intercom, as well as different controller. In this case, I'm showing using EMBA Plus, that we support EMBA Plus as well for control those cards. The other application I'd like to show is when you have a small network and you don't need to acquire PTP Grandmaster grade broadcasts. You can use IGGY devices as a Grandmaster, and you can provide a clock, or you can use an internal oscillator to generate the synchronization for PTP. So this is a very simple application. As I said, it's not a broadcast grade PTP, but it's good enough for applications, and you can dedicate one device to be the PTP Grandmaster, or you can make it completely automated, so any device can become a Grandmaster if the other one turns off or goes down for any reason. So this is a very good application for small studios or a small network. So the other thing that is interesting is IGGY plays really well in the 2110 environment. And you can see here in this, I'm showing Newt, which is our video over IP converter, and setting SDI to graphite, which is our all-in-one compact switcher. So you can grab the audio from your devices and then send to the network. And as I said, the network can be running 2110, and it's going to work really nicely. And then you can combine those audio feeds to your video feeds, and then you can do all kinds of things. This is just showing a use case for your Tally and GPIOs. The other thing I'm going to show, another innovation, is you can send commands, GPIO and Tally, from any device. For example, the AES67 on the top, the flyback can send commands to the MADI at the stage box, or the MADI connected to the audio console, and vice versa. As well as it can receive from dedicated devices or from a computer that is connected to the network, as long as they use the raw stock. I'm going to talk a little bit about that, and the TS Tally protocol. So you can see, you can also send commands from our devices, Ultra Carbonite, which is another production switcher that you can send commands, and dashboard. And it's very flexible, and there are many ways to control those GPIOs and Tally. I'm going to talk a little bit about the demo. I'll concentrate the demo on the innovation points, but I'll go quickly in some of the tabs. So this is pretty much the flow. I'm going to talk about the basics of the demo is going to be concentrated on the IGGY AES67, and I'm going to show how to set the interfaces, PTP synchronization, make some connection, and talk about some common problems. So this is a diagram of IGGY AES67. You see on the right-hand side the network interfaces. You have a NAT1, NAT2 for 22-7 redundancy. NAT1 is actually PoE, and then you can supply power from this interface or from a dedicated power supply. And you have the word clock input and output. On the left side, you have the DSUB interfaces for your AES3 interfaces and the Tally and GPIOs. So this is just showing the a little more details in terms of numbers. And what I have today in this very simplified network, as you know, everybody's working from home here at ROS, besides the manufacturer. So I have a small network here to do demos and to do debugging when necessary. And this has basically our Bach Liberty module, which is a 64 channel max module. And then we have the IGGY AES67, and then a Bach open module with it goes up to 512 channels. So I'm going to be controlling from a dashboard interface. I'm going to talk a little bit about dashboard. So I'll go quickly through the slides, and then we switch to dashboard to talk about the details. But basically, I'm going to demonstrate how to add IGGY to dashboard, and then talk about how you adjust your ports I/O, and then look at the status, about the PTP configuration, and show about some things you can do for network delay, offset from master. We're gonna take a look at that, and then finally we're gonna create some senders, and then make some connections according to looking at some advertised RAVENNA streams. So now the first thing I wanted to show is dashboard is, as you know, is an open source, an open controller that ROS, together with other vendors, developed to control OpenGear. Bill can add more information on that. But basically, it's a controller you can download for free, and then you can control many devices, not only ROS devices, but devices that support OpenGear. Or if you just wanted to use as a controller for your device, you don't need to be connected to OpenGear. You can use that. So one nice feature from dashboard is what they call the walkabout. Walkabout is if the device supports walkabout, it's a nice way to identify the device on the network and to find out the IP address. So if you have a device and you don't know the IP address, you just launch walkabout, and then you look for the device in the network. Right now, IGGY is my only device that supports walkabout. The other two modules I'm using a beta load firmware that does not support. But you can see here quickly that it shows the device, and it shows all the ports the device has. And you see the star. The star is actually showing what interface is connected to the network that walkabout found this device. So the other thing you can do is you can change the IP address in the NAT masking gateway from this interface, and then you can reboot the device. And the other very nice thing you can do is you can click on locate, and this, what it does is it flashes all the LEDs at once, blue color or green, or it's gonna be changing the color. So it's easy for you to see the device on the system, because sometimes you don't know physically where the device is. So imagine you have like hundreds of devices and you don't know exactly where it physically is. You can press in locate, and then the LEDs will be flashing, and then you find this device. So once you have all the devices, so imagine you're gonna see a bunch of devices here, and then you can be controlling here and then change the IP addresses as you wish. After that, the device will appear automatically. In this case, it's already here because I put it just before the presentation. But it finds the device, and this is what it is. So the other innovation I want to talk about is IGGY. The IGGY family has what you call the wizard. It's the steps the minimum steps you need to make a connection. So a lot of stuff in the default are ready for a connection. But if you don't want to go into many details or many things, you want to just do a quick connection, you can just come here to the wizard, and then you can change a few things. Of course, you can change the name of the devices, you can modify the IP addresses of the networks. You can also have some help if you have any question related to anything. As you can see, I left the network to link down for just to show you a few things. So the help also shows some pictures, so you can see some connections if you don't remember that. And of course, PTP and other global settings like sample rate, audio sample, sorry, number of channels, and so on. So this is a pretty quick way to make a connection. And of course, you can go to advanced, and then you can see all the same things here as you can see on the wizard with more details. So this is the interface for the I/O, so you can see some interesting information about the bandwidth being used. So this is actually measured. So right now I'm receiving and transmitting, so that's why you can see here. And you can establish you can do DHCP or static, as we talked. And PTP, you have a very flexible way to use PTP. Right now is a slave, but it can become a master. You have all kinds of, we have the protocols, profiles that we support, as Bill said. And the status, you can show the status of your interfaces, and you can see also the device status. For example, we have alarms that you can disable and enable. As you can see, I disabled this ink start of the NAT2. If I put it back, the status is going to show the link down, and then I can see that the device becomes red. And then I go to this page, and quickly I can see where it is, and then it tells, oh, there is something wrong with your network, your media link interfaces. So I can come over here and see what's going on. If this is something that it's okay for me, I can just go to alarms, and then I disable that. And then, of course, the status will not show that anymore. Even though if I go to the device, you can see that. So this is a very interesting stuff. So to make connections, there are two ways to make connections. You see the two interfaces here. Those destinations, I can change them. I can make it in number of channels per destination. So as I showed you, it has two DSOB interfaces, and those two DSOBs can be separated in number of channels. So I can have, for example, 16 or 2 or 8, and that's going to give me the number of destinations. So if I have 2 channels per destination, it's going to give 8 destinations. So basically, you have the destination, and below you see the streams. You can have preset streams that you can, for example, create manually streams here. So if you want to create streams, you can create him, and then you can give an icon so you know what they are. Or you can have advertised stream, which is all Ravenna advertised streams. So you can make connections. So it's a very simple way to make connection. Just select the destination. And right now it's connected, but you just select that. I'm going to disconnect that as well. So basically, you just choose the destination you want to connect, and then you just click on the stream you want to connect. And then you can do, for example, only the manual, the preset one. So you can select that and then make a connection. And after you do that, you can take a look at your receivers just to look at some information, the status and the bandwidth location, and you can see also the cross connect. So if I go there and then I disconnect, for example, destination 2, and then go back to here, you can show that the channels 1 to 8 are taken by destination 1 and the other channels are available. So this is a very good quick indication how my audios are being used or mapped. Right. So the other way around, you can set up sources. You can create a source. You just click here. You select the codec. You can select a specific net to leave it auto. And then if you set the audio, you don't care about the transport IP. If you apply it, automatically it's going to create an IP for you. And when you click on it shows the bandwidth allocation, so you can look at how much you still have or it's available for you to use. So the other thing I wanted to show is the GPIO and tally. So as you can see, it's completely flexible. You can change input and output as well as the display mode. You can select many ways to display, and you can set up message. As I told you, you can use raw stock or TSL, a few options for TSL, and you can select, of course, the device you're gonna send. So you can send the message you prefer, and you can set up triggers. You can trigger from an input, or you can trigger from a message. You have a source as a message or as GPIO. And then, of course, you can look at your inputs. You can monitor your inputs, and you can change your outputs. It depends on how you want to do it. So you can do it locally to this device, or you can do it to the other device if you want to set message. So the other thing I wanted to show is also a very interesting innovation is some debugging options. You can capture, if you want to take a look at some of the, for example, debugging PTP. So you don't know what's going on PTP, so you can capture, you can do a PCAP for the interface you desire. For example, ET0 is control, 1 is net 1, and 2 is net 2. So you can go up to 5 minutes of the PCAP, and you can also request a debug. It shows all the logs. It creates all the logs, and then you can have a file that has all the information for your logs. And then you have the tail here, just showing the last important message. So you can do a refresh, and then you can get the last information. So this is a very good debugging tool. So you can use it. It's a very nice way to debug when you need it. So the discovery mechanism in MOS it's still under, even though we have a prototype, but we claim it's coming soon. We have RAVENNA, EMBA Plus, SAP, RTSP, SLP. So there are a few ways to advertise these streams here. So I think now I can go back to the presentation mode. And if you guys have any questions on this, I can come back, or I can answer right now if you have. The other thing I wanted to show, I almost forgot, is the audio gain. You can control the inputs and the outputs as well as your destination. So you can change the gains for your interfaces. Very simple. And you can control individually, or you can control as a group. All right, so if you don't have any questions, I'm gonna switch back to the PowerPoint presentation and we go from there. So the other thing I didn't want to talk, it's just because I'm also responsible to help customers and some end users in terms of debugging. So a very common problem, and I think you guys know that, but it's never, you know, a lot to talk anymore. But anyway, so sometimes you cannot even ping the device. So it's a very basic thing, but people forget some. For example, the network mask or VLAN. It's very common for people call me. I can't ping my device, and then we're gonna do some investigation, see that the VLAN is wrong in the switch or wrong port. PTP also, in the past we used to have more trouble with PTP. Now people are getting more and more knowledgeable about that, but it was very common. The problem common today is sync interval and announce interval. The domain and profile are not as problem, but sometimes they put a different sync interval and announce interval, and then you see instability on that one. And of course, when you have all your network set and the PTP working, and then you don't have audio, what is going on? So usually is a packet time mismatch or codec mismatch, or when you have audio but it's glitching, is take a look at the PTP, it's really locked or not. Sometimes you can hear those glitches because PTP is unstable, and you have to guarantee PTP is really stable before you're trying to do any connection audio. So this is pretty much what I have. You can pass. I can pass back to Bill. Thank you very much, guys. If you have any questions, I'll be available. Okay, Bill, you can take over.
Sorry, on this website, I've included some more links for more information. The first link will give you more information on IGGY. I've also included a link to our IP bridges and converters. So this is general information, which includes information on our video converters, bridges, and gateways. The third link references our BOC OEM technology, RAVENNA AES67 technology, which is what we use actually in IGGY. And finally, I create a link to some more RAVENNA information. In addition to those links, feel free to contact us directly, and I've included our email addresses on the slide. So now I'll turn it over to Andreas.
Okay, thank you, Bill. Thank you, Angelo, for this highly interesting presentation on the ROS IGGY, a really versatile product, as you can see. That concludes your part of the presentation, and we directly change over to the Q&A part. I'm calling in Roland here to check if we have some questions, and encourage the attendees, of course, again, to use the Q&A function if they have any questions related to the just seen presentation.
Yeah, I haven't got any more questions. I had one that I was able to answer during it, or they said that was answered during it. Something came up, but then it was sort of answered by what you guys said. So no, it was very comprehensive, absolutely great. So if there were any more questions, we'd be very happy. But other than that, you know, you said it all. It was great.
Okay, thank you.
Thanks. We can all get some more time back to our.
Yeah, sure, of course. So yeah, before we finally close this, I'll of course have another link to share. Of course, we have the link to the IGGY platform at the rosvideo.com, and as always, you'll find a lot of additional interesting stuff and resources on the RAVENNA website under the link just provided here. So that's it for today. You made it. You get back about 20 minutes of today's schedule. And as always, recording and slides will be available in 1 day or 2 on the RAVENNA website. So thank you, everybody. And thank you, Bill, Angelo, and Roland again. Hope to see you soon. Stay safe.
Okay.
Goodbye.
Thank you very much.
Thanks. You too, Andreas. Stay safe.
Thanks. Stay safe, guys.